The Stardust mission, launched by NASA in 1999, was a groundbreaking endeavor that marked the first time a spacecraft returned samples from a comet to Earth. After a 5-year journey, Stardust flew within 155 miles, 250 kilometers, of Comet Wild 2, a comet that likely formed beyond Neptune and currently orbits the Sun between Mars and Jupiter, and collected samples of cometary and interstellar dust using a low-density silica-based substance known as aerogel. The aerogel sample collector was attached to panels on the spacecraft to gently capture cometary dust particles from the coma of the comet. The collector was deployed on December 24, 2003, and retracted about 6 hours after the closest approach to the comet on January 2, 2004. The sample collector was then sealed in the sample vault of the re-entry capsule. During its encounter with Comet Wild 2, Stardust captured 72 high-resolution images of the comet's nucleus. This historic mission provided scientists with the first opportunity to directly study material from a comet, offering valuable insights into the formation of the solar system and the composition of comets. Stardust was a pioneering mission with several notable achievements. It was the first spacecraft to bring samples from a comet to Earth, the first American mission dedicated solely to studying a comet, and the second robotic mission designed to bring extraterrestrial material to Earth. When Stardust launched in 1999, many scientists expected the comet's rocky material to be dominated by the primordial dust that the solar system was built out of, the stardust that the mission got its name from. But the actual samples told a different story. Wild 2 contained a mixture of dust that formed from different events early in the early history of the solar system. Since the comet spent its entire life in the cold vacuum of space, it avoided alteration by heat and water seen in asteroid samples. According to Ryan Ulyore, an associate professor of physics and arts sciences at Washington University in St. Louis who has been studying the Stardust samples for several years, Comet Wild 2 contains things we've never seen in meteorites, like unusual carbon-iron assemblages, and the precursors to igneous spherules that make up the most common type of meteorite. And all of these objects have been exquisitely preserved within Wild 2. In addition to its primary objective of collecting samples from Comet Wild 2, Stardust also gathered interstellar dust as it flew by asteroid 5535 Anne Frank during its mission. The successful return of the cometary and interstellar dust samples to Earth opened up new avenues of research and has continued to yield valuable scientific discoveries. The samples collected by Stardust have provided insights into the composition of comets and the processes that shaped the early solar system. The mission's significance extends beyond its initial achievements, as the samples returned by Stardust continue to be studied and analyzed by scientists. The valuable data obtained from these samples has contributed to our understanding of the formation of the solar system and the role of comets in this process.